Very warm greeting to all the viewers. In this video, I'm going to explain one of the most common non-destructive test method of casting, that's magnetic particle inspection. Moving on to the principle of magnetic particle inspection, or MPI in short. MPI is used to find out cracks on the surface or on subsurface of any ferromagnetic casting product. So how do you find so? You take the ferromagnetic cast product, apply the magnetic field lines to it, and if there exists any crack, there will be a causing of magnetic flux leakage as shown. In order to track the magnetic flux leakage, you apply some magnetic particles on the top surface and then look for some clustering of magnetic particles. If you find so, then you can conclude saying that there is a leakage of magnetic flux, and which says that your cast product consists cracks. This is the theoretical aspect of MPI. Now let's see how it's involved practically. Practically, the first step to do is that magnetize the casting product, and magnetization can be done in two ways. First, direct magnetization, and second, indirect magnetization. In direct magnetization, you employ the test product itself in producing the magnetic field lines as shown. But this is usually not employed nowadays, since there is risk of production of arcs or burning on the test product. In the case of indirect magnetization, permanent magnets are used for producing magnetic field lines, which again is not in practice nowadays, because you cannot control the magnetic field lines anyhow. Nowadays, the most commonly or the only way used nowadays is using yoke. In yoke, you have two magnets in which the magnetic field lines are controlled using an AC or DC current, in which you can increase or decrease the magnetic field line intensity. This is the first step, being to magnetize the casting product. Moving on to the second process or the second step. After magnetizing the specimen, you apply magnetic particles on the magnetized specimen. And again, the magnetic particles are of two types. One is dry, and the second type being wet or suspension of magnetic particles. In dry, you put the magnetic particles on the top surface, and in second case, when in suspension, you have the inspection done under visible light, whereas you have the inspection done under fluorescent light. In the under visible light category, first you have to apply a white paint, and on top of that you have to apply the suspension of ferromagnetic particles. Whereas in the fluorescent light, you need not apply any white paint. You can directly apply the suspension of ferromagnetic particles. And this being the second step. Moving on to the next. The third step being the inspection. In here, you find out the cracks on your ferromagnetic cast product. And how do you do so? Saying in the dry case, you first blow out the ferromagnetic particles, and then you look for the clustering. And here you see the crack. And here you see the clustering of magnetic particles, and thus you can say that there is crack on your cast product. Whereas in the case of wet or suspension of ferromagnetic case, you use a visible light of 1000 lux minimum, and then you find out the cracks here and here and here. In the case of fluorescent light, you need a light intensity of 1000 microwatt per centimeter square, wherein you apply a UV light on top of the surface and then dim the surrounding light, and this is what you see. And here you see the cracks. So fluorescent light is more sensitive to tight cracks, in order to find tight cracks, fluorescent light is mostly employed. This being the third step. And moving on to the final step, demagnetize and cleaning the specimen. Within that, there is one more catch in the process. Application of field lines in particular direction, you might only find cracks only perpendicular to that field lines, which in turn I say the horizontal cracks are not found out in this action or in this process. So in order to find out, or what I mean is that by applying the magnetic field lines in this way, you only find out the vertical cracks, which is shown here. So in order to find the horizontal cracks as well, what you do is that practically we apply the magnetic field lines in the circular manner so that you get the horizontal cracks as well. So this is how you employ practically MPI. And that's the end of the process of MPI. Moving on to the pros and cons of MPI. The advantage being its simplicity and getting the result within a few minutes of time. And the cons, and the basic and the most common con, is that it's only applicable to ferromagnetic cast products such as iron, cobalt, nickel, or the alloys of them. Finally, last but not the least, I would like to show my courtesy to foremost Dr. A. Goswami for his unkindled support, guidance, and help throughout. For without him, this video wouldn't have been possible. Also, my courtesy to all my virtual helpers and well-wishers. Thank you for your support. Thank you for watching, and have a nice day.